All right, here are solutions for our first quiz for Math 112. First problem, you're given three different functions, one-to-one functions it turns out, and told to find the inverse function in each case. I guess you're given two different functions. I think I had a different version where you're given three. Anyways, to find the inverse function, the way I taught you to do it is first there's kind of this meaningless step that you could probably skip if you felt like. But just know that later on you're going to do algebra, and it's easier to do algebra if this is a y instead of an f of x. So change it. Fine. Here's an equation that represents the function. But you don't want an equation that represents the function. You want an equation that represents the inverse function. But it turns out that the equation that represents the inverse function is very similar to this. The only difference between the function and the inverse function is you're switching your inputs and your outputs. So I can come up with an equation that represents the inverse function by changing all my x's into y's and my y's into x's. If you do so, you'd end up with something that looks like this. And then from here, all you have to do, and use the term or the word all very loosely, is solve for y. Unfortunately, it's pretty hard to solve this equation for y. What's problematic here is you have two different y's. There's a y hanging out up here and a y down here. But the trick, as you saw in the homework, is first take care of the y down in the denominator. And by take care, I mean multiply both sides of the equation by 2y plus 3. Make it so that you don't have a y in the denominator anymore. Get to here. And the reason this is preferential to this up here is what I can now do is collect all the terms that have a y in them on one side of the equation. So move all the terms that have a y in them on the left and the ones without a y on the right, if you want left and right. But it's a little bit hard to do with these parentheses. So okay, get rid of the parentheses. Get rid of the parentheses by distributing that x through the parentheses. 2xy plus 3x is equal to y. And now I can subtract y from both sides of the equation. And then subtract 3x from both sides of the equation. Get to here. And the advantage to having each term, here's one term and here's another term, have a y in it, is I can factor out a y. Factor out a y, and you're left with 2x minus 1. So to solve for y here, I can just divide both sides of the equation by 2x minus 1. End up with something like this. Just an FYI, this is equal to 3x over maybe 1 minus 2x. These two things are equivalent. Actually, I don't want to box those. Well, whatever. They're equivalent. All I did is I multiplied the top and the bottom of the fraction by negative 1. I made this positive, and then it made this negative 2x plus 1, which is the same as 1 minus 2x. So either of these work. And really, I probably should have written f inverse of x equals one of those two guys down there. Part B, do the same thing. Different function, so different algebraic steps, but the first few steps are the same. Change g of x into a y to make your algebra easier to do later on. And then change all your x's into y's and y's into x's so that you can come up with an equation that represents the inverse function instead of an equation that represents the function. And then solve this thing for y. It might look a lot worse than what we were doing up here, but this one's actually easier. Down here it's really problematic having multiple y's where I can do some algebraic tricks. Down here I only have one y. I can isolate it. To isolate it, add 1 to both sides of the equation. And divide both sides of the equation by 2. And then take the cubed root of both sides of the equation. Subtract 4 from both sides of the equation. And finally, square both sides of the equation. You get y equals the cubed root of x plus 1 over 2 minus 4, that whole thing squared. And I guess if I'm going to write it in the right notation, I should say g inverse of x is equal to, and then copy that mess that I just wrote down there, cubed root of x plus 1 over 2 minus 4, and That quantity gets squared. All right, moving on, back page. You're given 3 graphs. One of these graphs, 2 of these 3 graphs are graphs of functions. One of them's not. So how do you determine what graph represents a function? Well, there's this vertical line test. I guess it's probably the easiest way to do it. To be a function, maybe I'll write this. Briefly justify your answer. Either using the vertical line test or noting that a function must have at most one output per input. We see that graph A, is that what I called it? This first guy here. Graph A is not a function. If you drew this vertical line, for example, it intersects my graph in 3 different places, so it doesn't pass the vertical line test. Part B says, okay, that leaves you with 2 graphs here. One of them is 1-to-1, the other one is not. Which one is not 1-to-1? Either using the horizontal line test or noting that a 1-to-1 function must have at most one input associated with a given output. We see that graph 3, or C, I guess, is not 1-to-1. What I'm saying is, if you did a horizontal line test with this line, for example, you'd see that it crosses at all 3 of these points. In other words, if you put in this x-coordinate or this x-coordinate or this x-coordinate, the same y-coordinate comes out. You have multiple inputs associated with the given output, so the function is not 1-to-1. C is not 1-to-1. And then finally, part C says sketch the inverse of the 1-to-1 function. Maybe I'll say C above. And I will sketch the inverse of this function. This function, it looks like, goes through the point 0, 1. Nope, that's not true. It goes through the point 1, 0. So therefore, its inverse must go through the point 0, 1. It looks like this graph goes through the point -1, -4. So its inverse must go through the point, you know what, I shouldn't make that many blue dots. This dot goes here, and this dot goes here. Is that -4? 1, 2, no, that's -3, sorry. So I need to draw something that goes through those points. Okay, well, it's a straight line from here to here. So it'll be a straight line from here to here. But what about up here? Well, let's see, this is the point 1, 1, 2, 3, 1. So my inverse must go through the point 1, 1, 2, 3. This point right here. So points that I want to make sure my graph goes through are these guys, which is going to give me this shape. And down here it looks like -4, -4. So therefore the inverse should go through -4, -4 also, and end up with a graph like that. And I guess that's it. That's the end of this quiz.